Okay, guys, so I'm going to walk us through the Chapter 4 test review, just kind of explaining the problems. And hopefully, any questions you might have after this will clear that up. Um, I'm going to focus more on the proofs in 4.4 and 4.5 that we didn't really get to talk about together. I'm hoping this first page went well because we've been doing so much with congruent triangles. You had 3 mini quizzes on this, and we've talked about it a lot in class. So, again, I'm hoping that, these first 8 went well. Um, yeah, so 1 through 4, you weren't even really giving, you were just telling me if they were or weren't congruent based on why. Um, Here you were telling me why they're congruent and the congruent statement. So again, hopefully these went well. Let's see here. 7 and 8. I will go ahead and say, that you won't have anywhere you have to explain like this. It was just kind of good practice to make sure you're understanding why you're marking and how you should mark things. But you'll have more problems like 5 and 6 on your test, basically, when it comes to these. So if you have any questions on this first page, please feel free to contact me and I'll gladly answer any questions on them. But I'm going to spend more time on the newer questions. Okay, so 9 through 13 are using the different types of triangles you learned in 4-5. So 4-5, you learn about isosceles and equilateral triangles. So 9 and 10 are both isosceles, and really the key thing for 9 is realizing that since these are congruent, these two sides here, since those two sides are congruent, then these two angles across from the sides have to be congruent as well. So basically, I said that since this is x, that has to be x as well. Well, we have an alternate exterior, or not alternate exterior, we have an exterior angle here and two remote interior angles. So basically, this x plus x would give you 116. So that's how I came up with this equation. And then I just solved for x. You could also have used that this was a linear pair here. So then you would get a number here and then subtract, and then take that plus x instead equal to 180 as well. So either way is fine as long as you get 58 for x. 10, again, we have an isosceles. So what you should have noticed is these two angles given to you should be congruent because they're across from those congruent sides. So you just take 4x plus 20 and set it equal to 40. So that's how you would do 10. 11, you have an equilateral. So all the angles are going to be 60 degrees. So you should have taken this 3y plus 9 and set it equal to 60. And same for the 5x minus 10. So you should have set both of those equal to 60 and solve for y and x because it's an equilateral triangle. So that's those three. 12, they gave you this 4x plus 10 here, and then this 40. And once again, since this is what we call isosceles, the angles across from those congruent legs here, so here and here, these two, those are going to be congruent. So that's why they're both 40. So that's where that one comes from. So then this is a triangle, so all these angles add up to 180. So 40 plus 40, which is 80, plus 4x plus 10, which I have right here, equals 180. And then you just solve for x. 13, you have this 5x here, and both of these triangles are their own separate isosceles triangles. But really, you only need this one right here. So, this one right here. So for this one, you have vertical angles, so you can get the 2x here. And if this is 5x, this has to be 5x because the sides across from the congruent sides, the angles across from the congruent sides are congruent. So then you add all those together and set them equal to 180 because it is a triangle. So 5x plus 2x is 180. So that's 9 through 13. So hopefully that clears up any questions there. These numbers, 14 through 17, including 18 here, is really just using CPCTC. So you're looking at your congruent statement. All right, so we got our congruent statement. Then you're telling me, all right, based on that statement, JK is congruent to whatever. So hopefully these ones here went well for you. Um, oops. Oh no, I didn't mean to do that. Crap. What did I do? There we go. Sorry. So hopefully these went well for you because all these are kind of a review. Yeah. And remember, CPCTC, corresponding parts of congruent triangles are congruent. That is important here, so don't forget that. Okay. 19. For problems like this, 19 and 18, or 19 and 20, sorry, draw pictures. Pictures will help you. So for 19, you have triangle KJM. That's isosceles with KM as the base. So that's what this picture is right here. So I got KJM. KM right here is my base. These two sides then are the two congruent sides. And then I labeled everything that was given to me. So this is my picture. Based on this picture, you can now see, okay, if this is an isosceles triangle, again, we know that the two sides that aren't the base are congruent. So that means to find x, you take this 17x minus 8 and you set it equal to the 15x minus 2 here. So that's how you get the following equation. So that's where that one comes from. Okay, let me try to get, there's usually a way that I can get. Here we go. A pen. Sweet. That'll help. Oh no, it went away. Never mind. Oh well. Okay, but anyways, so then you set them equal each other, solve for x. That's how you get x. To get the base and the leg then, so the base is km, so you plug 3 in for 5x minus 5. The leg can be either of these legs, so I plugged it into the 15x minus 2, and that's how you get those lengths. So that's 19. 20, this time you have an equilateral. So again, I drew a picture, I labeled the sides. An equilateral has all sides that are congruent. So I kind of indicated that right here. So to find y, you just got to pick any two sides. It really doesn't matter. You can pick any two. I did 7y plus 3 and 5y plus 13, and you get y to be 5. And then you just plug that in to get the side length. But again, you could do either of them. You could do 8y minus 2 equals 5y plus 13. Or 8y minus 2 equals 7y plus 3. You can use anything because all the sides are congruent and you'll still get the right answers. Key part for these, draw a picture. It helps. All right, now for our proofs. Let me zoom out here a little bit. This is a little, oops. There we go. Okay, 21. So you're given that BD is perpendicular to AC and D is the midpoint of AC. So that's given to you, that's already written down for you. And then they kind of help you out. So then they tell you to use the fact that if BD is perpendicular to AC here, then ADB and BDC are right angles. So I labeled that in the picture. Hopefully you did that as well. And that's the definition of being perpendicular. So that's that. And then from there, they tell you that all right angles are congruent. So you can say that these two angles are congruent to each other. So that takes care of the perpendicular part because you got to take care of definitions. The other definition is midpoint. So then that's step 4 here. You should say then if D is the midpoint, then AD is congruent to DC. That's definition of midpoint. Okay, then as you go through your list, you find that there's no parallel lines, there's no vertical angles, but there is a shared side, BD right here. And you need to say BD is congruent to BD. It has to look like this, right? It's got to be the same order, and then it's the reflexive property. And from there, you should have marked 3 things on your picture, and you now have side, angle, side. So the two triangles are congruent. Since you're proving triangles are congruent, you don't use CPCTC here. You just stop once you get the triangles to be congruent. Okay, so that's 21. 22 here. This one, they already give you that WX is congruent to WZ. You should mark that right away. As soon as you see that's given to you, mark it, as I did here. So I marked here and I marked here. Okay. And then they also tell you that YW bisects angle XWZ. This time we're proving that parts of our triangle are congruent. We're proving that XY is congruent to YZ. So if you want to, since you know you're proving parts of the triangle congruent, you can write that down as your last step, right? XY is congruent to YZ, and that's going to be because of CP/CTC. So you can always do that. Just remember, that's always going to be your last step if you're proving parts congruent. So when we go through our list of things to do, we need to start by defining a bisector. Well, if it's an angle bisector, we're bisecting X, W, Z, we're splitting this angle in half. So I marked angle 1 and angle 2 are congruent, and that's what I have written here. That's definition of an angle bisector. Okay. And then as you go through your list, the next thing you will notice is you have a shared side. YW right here is a shared side, so I marked that. You now have 3 pieces of information. So WY is congruent to WY by the reflexive property, and by side, angle side, those triangles are congruent. So that's 22, and then you're ending with CP/CTC. Okay. 23, you have parallel lines and a midpoint. So when you write down your given, the first thing you want to do is define midpoint, which I did. Y is the midpoint of BZ, which is this line right here. So I marked YZ and YB to be congruent. So ZY is congruent to YB, definition of midpoint. Then you have parallel lines. So with the parallel lines, you have 2 options of angles that you could say are congruent using alternate interior angles. You can either do X and A, or you can do Z and B. It depends on which one you pick. You can pick either one, but your answer here is going to be dependent on which one of these 2 you pick. And then you have a pair of vertical angles here. So XYZ is congruent to AYB because vertical angles are congruent. At this point, your triangles are congruent by either angle side, if you use this one right here, so the boxes go together, or angle side angle if you use this one. Doesn't matter which one you use. I really don't care, just as long as you're getting your congruent triangles. And then once again, we're proving parts congruent, so you're ending with CP/CTC. Awesome. All right, last proof here. Uses a little bit of vocab. I'm going to zoom out a little bit more. There we go. Okay, so we got a little bit of vocab here. It says triangle PQR is isosceles with the base PR. And S is the midpoint of PR. And we're proving the triangle is congruent. So we have no CP/CTC here. You're just proving them congruent. So you start by writing your given. Now you need to define your different words. We have midpoint and we have isosceles that we have to define. I defined this isosceles triangle first because if you have an isosceles triangle, the sides that aren't the base are congruent. So PQ is congruent to QR. So PQ, QR, those are congruent. And that's a definition of isosceles triangle. Then I used the definition of midpoint. Well, if S is the midpoint here, then that means PS is congruent to SR, which I have right there. And then last but not least, you have another shared side. QS is congruent to QS by the reflexive property. So you have the triangles congruent by side, side, side. All right, guys, hopefully that helps you. After going through that test review, your test has very similar questions. It's quite like this review. You have 2 proofs on the test, one that uses CP/CTC and one that doesn't. You have you have showing why triangles are congruent. You're going to have like an isosceles triangle problem or equilateral. You're going to have some CP/CTC in there. So if you understand this review, you should be good to go. If you have any questions, just let me know. I'll see you soon.